Okay, so now we're going to be give you what the extreme value theorem says. Again, remember, it is a existence theorem. So it says if f of x is continuous, and that is extremely important, it must be continuous, on a closed interval. It has to be closed because you need to be talk about the endpoints. And then we'll call it AB. Then f of x has at least one absolute maximum and one absolute minimum. And that makes sense. Even on like a very basic graph, let's talk about that. It goes from here to here. Boom. I don't know what's really happening in between, but I'm guaranteed that this may be the smallest. But if it's not, maybe it's down here. Somewhere in here I will have the absolute smallest, and somewhere in here I'll have the absolute largest value. It's like a guarantee. It must be continuous. That is the big thing. If there is a hole or a vertical asymptote, it messes the whole thing up. Okay. So now we're going to look at our first example. When we do these examples, basically you need to figure out what is happening at each of the endpoints and what is happening at each of the critical values. So those critical values are either going to be maxes or mins, and then your endpoints you need to compare to those and decide if they are larger or smaller. All right, so, and like I was looking at this one, we probably want to use a calculator for this one, and I'll show you why. Because if we take the derivative of this, we get 3x squared minus 4x minus 3, and you set that equal to 0. This doesn't factor very nicely, and so you probably want to just go through the quadratic formula. So what I would do at this point is go ahead and pause this video, take a few minutes, and put these values into your quadratic formula or into your calculator, or you could graph it and try to figure out where the x values are. So just take a second to do that. Okay, welcome back. Hopefully you found out that x has a critical value at 0.535 and at 1.869, I think, is if I'm looking at my notes. All right, so here's what we need to do now. We need to figure out what is the value of the function at the first endpoint, what is the value at the function at the last endpoint, and then what is the value of the function at each of the critical values, because those critical values could be either maxes or mins. And then we compare. And the one with the highest value is considered the absolute maximum, and the one with the lowest value is considered the absolute minimum. All right, so I plug in -1 into the original function, make sure it's the original function, and when I do that I get -2. And if you need to pause the video right now to actually plug that into your calculator, please do so, but it's -2. Now I'm going to do the same thing for 0.535. This one's a little bit nastier. So one thing you could do on this is to graph the original function, do a trace, and then type in the number 0.535. But you have to hit trace first. And then when you do that, it gives you -8.065. Again, I'll repeat what I did. You could type this in by hand, which becomes kind of a pain in the butt. Or you could graph the original function, hit trace, and once you hit trace, type in 1.869. When you do that, and I just read my notes, I realized I wrote this down wrong. This is -8.065. This one up here is -1.121. Sorry, make sure you did that. And then now I type in f of 3 and I get -2. Now I start comparing. Which one is the absolute maximum? And so my absolute maximum, we'll call it abs max, that's going to be at y equals -1.121. And my absolute minimum is going to be at y equals -8.065.